As stated by recently publications of the Oxford Institute for Energy Studies, the IMO, as the industry's principal regulatory body, aims to reduce world shipping's greenhouse gas emissions. Currently, the shipping industry represents 3% of global GHG emissions. In such a scenario, the role of sustainable fuels based on hydrogen and ammonia is constantly gaining relevance. Forecasts in shipping growth predict that in 2050 the cost of the emissions will range close to $1 trillion, assuming operations totally compliant with regulations. Furthermore, it is important to know how viable the different renewable energy sources are for the shipping sector, and analyze the pros and cons of each alternative. The use of electrical energy from renewable sources is one of the probable scenarios. But the battery technology is not enough to cover the entire supply. In addition, the use of batteries poses another sustainability threat. On the other hand, the liquid hydrogen has potential capabilities to be used for long-distance displacement. Green ammonia is a viable midterm solution capable of being produced by sustainable production methods. Hence, the viability of green ammonia is currently high. Nonetheless, alternatives such as methanol or palm oil face the challenges of not being sustainable generated, coupled with difficulties to be produced on industrial scales.
Once stated the relevance of green ammonia in the era of decarbonization, the means that can be used for its production have to be explained. The market of green ammonia production, according to a study carried out by energy departments based in Switzerland and Italy, accounts 50% of global production, scattered across China, Russia, the United States, and India. The production of green ammonia currently depends on industrial processes such as biomass gasification and water electrolysis. However, in both cases, the advantage that ammonia production represents is that it has a relatively low production cost. Nevertheless, the current section will be aimed to explain how does the processes of biomass gasification and water electrolysis work. The process of biomass gasification consists on transforming biomass into ammonia. The biomass is a plant-based material, such as wood residues, agriculture residues, and waste from industries, farms, and households. The biomass produces syngas, which is a mixture of hydrogen, carbon oxides, and carbon dioxides. Firstly, the syngas are introduced in a water gas shift reactor, which increases its content of hydrogen. Secondly, the enriched compound passes through a process of acid gas removal and methanation, in which the high-purity hydrogen is derived from the rest of the compound. Inferably, the carbon portion of the syngas is transformed to CO2 that can be completely captured. Depending on the source of biomass, the cost of production in the biomass gasification process ranges from 500 to 700 euros per ton. In addition, the energetical efficiency of the process fluctuates between 40 and 70%. The process of water electrolysis, on the other hand, consists on the molecular separation of water via electric power in order to generate hydrogen. The milestone of the water electrolysis is the electrolyzer, which splits water into hydrogen and oxygen. However, the electrolyzer is more effective on higher temperatures. To achieve higher temperature of water, the electrolyzer is coupled with the Haber-Bosch process. The Haber-Bosch process requires of an environment of high temperature and pressure in which the air is introduced. Within that environment, the iron is used as catalyzer, thereby separating ammonia from the air. However, the cost solely using the Haber-Bosch process may result very high, but it can be improved with the inclusion of the electrolyzer. As a result, the combination of processes reduces the amount of energy which is required, ranging the final production costs close to 520 euros, depending on the labor costs and the cost of electricity.
The green ammonia as a final product is a compound with multiple commercial uses. The ammonia is widely used for the production of fertilizers, but it can also be used as a capturing agent in the removal of acid gases. Together with, the green ammonia can be used in refrigeration and air conditioning systems, as well as a raw material in the production of explosives, fibers, plastics, polymers, papers, and acids. Lastly, the green ammonia is also feasible for its utilization as fuel for combustion engines. Because of the multiple uses of the ammonia, its production has increased in the last decades, reaching hundreds of millions of produced tons at a global level. Nevertheless, the current section aims to highlight the flexibility of the green ammonia as a commercial product. The green ammonia is currently used as raw material in several industrial processes. Firstly, the ammonia represents a better alternative for the production of fertilizers. Much of the current alternatives in the market consist on fertilizers based on nitrogen. However, the current utilization of nitrogen is already exceeding the levels processed naturally on the nitrogen cycle. As a result, several nations have limited their production and consumption through several policies intending to mitigate the adverse effects of climate change. Therefore, the demand for ammonia-based fertilizers can be forecasted to increase. Secondly, the green ammonia can be utilized as capturing agent in the removal of acid gases. Following industrial processes like the Ostwald process, the green ammonia can be utilized for the production of nitric acid, an acid with a variety of commercial uses. Thirdly, the ammonia is also used to produce plastics, fibers, explosives, and intermediates for dyes and pharmaceuticals. However, despite the variety of commercial uses of the ammonia, the production levels of the former final products have remained stable. Because of that, the commercial use which can be forecasted to consistently increase is its use on marine bunkers. Several characteristics can provide ammonia-based bunkers with advantages in the market. The adoption of more sustainable methods of production allows such industries to maintain their production levels on future political environments. In other words, the green ammonia can be seen as a method to build cooperative resilience in a world of constant changes in governance. The green ammonia is an ideal substitute to be used in production processes which demand for a continuous heat source, such as those industries oriented to the steel or cement production. Similarly, popular industries, such as the shipping industry, will increase their operational costs due to increased stringency on regulations. Hence, the increase of operational expenses will affect the freight costs, thereby increasing the price of all derivatives which depend on shipping to be produced and exported.
The eve of the Anthropocene is making changes on the way that humans interact with their environment. Trends on the adoption of sustainable behaviors are gaining popularity among governments, policies, industries, and ultimately among the citizens. The extent of the popularity has reached the level in which final consumers increasingly prefer products that are labeled as sustainable options rather than normal goods. Due to such changes, traditionally accepted modus operandi in the fields of energy production, bunkers, agriculture, and logistics have to adapt and evolve towards greener alternatives. Within that process, hydrogen-based bunkers are continually being explored as potential alternatives with a relatively low cost. Green hydrogen is seen as a very promising driver for the decarbonization of energy systems. Its use is expected to account 20% of the world's energy consumption in 2050. By the same token, a study carried out at the Institute of Nanotechnology from the University of Twente, Netherlands, and the Plasmat Research Group of the University of Antwerp in Belgium also highlights the potential of the green ammonia to become one of the energy drivers in the near future.
Undoubtedly, the ammonia market is an increasing market. In addition, nowadays the production of ammonia can be seen as a perfect competitive market due to its relatively low access barriers. However, since the ammonia is an increasing market, its commercial price is constantly changing due to advances on production technology and demand levels. Nevertheless, the appraisal of the ammonia as final product can be determined depending on the means utilized for its production. For both processes, the appraisement can be done by assessing the costs of operation, production, and capital. The operational cost depends on the production time, costs of maintenance, and the cost of labor. Such factors do not behave in a volatile way and therefore tend to be very stable in many different nations. Secondly, the production cost depends on the costs of raw material. Depending on the production method, the raw material may include compounds such as household waste or wood. However, in both processes, the electricity costs have to be analyzed. Unfortunately, the electricity market is currently determined by the law of supply and demand, which makes the market highly volatile. Under such scenario, ammonia producers may result benefited with the adoption of mid-term contractual relations, which allows them to treat electricity costs as fixed costs for a determined period of time. Lastly, the appraisal of capital costs can be done by analyzing the cost of rent or the cost of bank loan payments. Coupled with capital costs also include the cost regarding the obtention of production technologies, which is the machinery used in transformation processes.
In conclusion, Hydrogen-based bunkers, such as green ammonia, are increasingly gaining popularity within the market. Its utilization as bunker is forecasted to increase as a result of changes on regulatory schemes. However, the different production processes of the ammonia involve the use of raw materials with volatile commercial values. Despite such volatility, some calculations can be performed in order to estimate the total costs of the product. Nevertheless, as the technology and science evolves, new commercial applications of the green ammonia are to be found and improved. Thank you so much for your attention.